Hi, my name is Melanie Escobar, and in this video, I'll be going through the tracing for the different sorting taught in this class. So I'll be tracing this array for these three. So for insertion, basically you get your key, and in the first case, your key is 1 because this right here is in itself already sorted. So what you're going to do is you're going to take the key and compare the sorted parts. So in this case, it's just only one element. 5 is less than 10, so we're just going to put it in the sorted part. 5, 10, and this part is considered sorted. So now our key is going to be 4. So 1, 6, 3, 9. And then we're going to compare 4 and 10. Because 10 is greater, we'll put 10 here, and then 4 and 5. And then 5 is greater, so we'll put 5 here, and then 4 will go here. So now 1 is our key, 6, 3, 9. This is what we'll be comparing to. So then we see that 1 is less than all of these. So 1, 4, 5, 10. And so now 6 is our key, and then 3, 9. And then compare again, so to these. So 1, 4, 5, 6, 10. So now 3 is our key. Compare again, so 1, 3, 4, 5, 6, 10. And then 9 is our key, so 1, 3, 4, 5, 6, 9, 10. And so now our array is sorted. For selection sort, you're going to iterate through this array, right? But you're also going to have a minimum value. So my iterator will be a circle, and my minimum value, I'll put it as a square. So the minimum value in the array after this iteration will be 1. So I'm going to swap both of these. So we see 1, and then 10, and then everything else stays the same. So 5, 4, 6, 3, 9. And then now go on to the next iteration, which is 5. We're going to grab the minimum value. In this case, it's 3. So 3 and 5 are swapped. So 3, 5 goes here. So 1, 4, 10, 6, 9. So now next iteration is 4. And then our minimum value that is our minimum value. So we're just going to go on to the next one. So 1, 3, 4, 10, 6, 5, 9. So now it's 10. We grab our minimum value. In this case, it's 5. So 1, 3, 4, 5, 10, and then 6, 9. And then 6. And then we grab the smallest. Well, it is the smallest, so we continue. 1, 3, 4, 5, 6, 10, 9. The smallest is 9. So 1, 3, 4, 5, 6, 9, 10. And there it is sorted. In bubble sort, you're going to start with the first iteration, and then you're going to bubble it until you hit the largest. So in this case, 10, after we keep bubbling, is the largest, so we stop here. So we're just going to bubble it over there. So 5, 4, 1, 6, 3, 9, and then 10 here, and it's going to stay like that. So I'm going to underline it, like we're not going to bother this 10 anymore. So now you're going to bubble 5. 5 is greater than 4, 5 is greater than 1, but we see that 5 is not greater than 6. So we're just going to do 4, 1, 5, and then now we want to bubble 6. So 6 is greater than 3, 6 is not greater than 9, so we're going to stop bubbling there. So we're going to do 3, 6, 9, and then like I said, we leave 10 alone. Now we are also going to leave 9 alone. Then we're going to do 4 and then start bubbling 4. So 4 is greater than 1, 4 is not greater than 5, so now we will bubble 5. So we're going to switch these two, so 1 and 4. 5 is greater than 3, 5 is not greater than 6. Here we see that we will put 3 here, 5 here, and 6 here, and now we do not touch 6. So then we do 1. 1 is not greater than 4, so 1 stays there. And then now we do 4. 4 is greater than 3. 4 is not greater than 5. So then 3 goes here, and then 4 goes here. And then now 5, we do not touch 5. 6, 9, 10. So then now we do 1. 1 is not greater than 3, and so that stays the same. And then we do 3. 3 is not greater than 4, so 3 stays the same. And then we do not touch 4, 5, 6, 9, 10. So you just keep bubbling. So 1 is not greater than 3, so we put 1, and then we do 3, and then we see we do not touch 3, so 4, 5, 6, 9, 10. And then 1, we do not touch 1, so 3, 4, 5, 6, 9, 10. So this is version 1, but where we stop at version 2 stops when we did right here. This is redundant steps that version 1 has, and then version 2 stops when we stop swapping. Yeah, so that's bubble version 1 and version 2. So now I'm going to do shell and merge sort. I'm going to start with shell. Essentially, shell is just a better performing version of insertion sort, but you're going to be comparing elements far apart from each other rather than your neighboring elements. We do this by using a gap. In this case, I'm going to use 4. I'm just going to compare the gaps. 8's gap of 4 would be 1, 2, 3, 4, would be 3. And then 4's gap would be, I'm going to do these lines basically to see what I'm essentially swapping, right? So 4's gap would be 1, 2, 3, 4 would be 7, the next one over from this one. So then 1 would be with 2, and then 6 would be with 5. So now I'm going to swap 3 and 8 because they're the ones together. 3 goes here, and then 8 goes here. And then now I'm gonna swap 4 and 7. So you don't need to swap them because they're already sorted. So 4 and 7. And then I'm gonna go ahead and do a swap of 1 and 2. They're already sorted, so we don't have to. Lastly, 6 and 5. Yeah, we do need to swap them. They're not sorted. So then we are going to lower the gap to 2. Now 3 will be in a gap with 1 and 8 and 2. And then 4, 5, 7, and 6 will be together to be basically doing insertion sort on the separate gaps. We compare 3, 1, 8, and 2. So then 1 goes here, 2 goes here, 3 goes here, and 8 goes here. And then we go ahead and do a comparison of 4, 5, 7, and 6. 4, 5, 6, 7, and then we do the lowest gap, which would be just 1. So then we would just do insertion sort in this one. So then 1, 2, 3, 4, 5, 6, 7, 8, and that's shell sort. For merge sort, you're just going to be splitting in half at the start. Just keep splitting. We split in half: 5, 99, 8, 12, and then 45, 23, 22, 10. And then you split in half again: 5, 99, 8, 12, 45, 23, 22, 10, and then split in half again: 5, 99, 8, 12, 45, 23, 22, 10. So as you see, they are all split. Now you're going to start sorting them. So you're going to sort from where you split last time. That would be these, right? We're going to swap these. We're going to swap these if they need to be swapped, right? 5, 99, they stay the same. 8, 12, they stay the same. 23 and 45 are swapped. 10 and 22 are swapped. And then we merge these two and sorting them. So 5, 8, 12, 99, 10, 22, 23, 45. And then put them back together, sorting them. So 5, 8, 10, 12, 22, 23, 45, 99. So essentially I just kept splitting at the beginning until we completely splitted them, and then we started merging them again, but also sorting them. So then we keep merging these, we merge them but sorted, then we merge these but we merge them sorted, and then lastly we merged it again but sorted this time. So that's merge sort. Here's heap sort. So heap sort, we're just gonna build a heap. The heap would be 5, and then next would be 10, and then 15, and then 6 would be right here, and 21 would be right here. So then if we want to do this in ascending order, we would build the max heap. If we want to do this in descending order, we would build the mean heap. We want to do this in ascending order, so we're gonna build the max heap. We see that 21 is greater than 10. We don't bother changing the children, we just want to change the parent to be the largest. So here in this case, 21 will be swapped with 10, and 6 will stay the same. We see that 5 will be here and 15 here. And then now we see that 21 is greater than the parent, which is 5. So 21, 5, and then this is 15, and then 6 and 10. We see that now 10 is greater than 5. So then 21, 10, 15, 6, and 5. This will be our max heap. I'm going to move this down because now we're going to start extracting. So here the array is currently at 21, 10, 15, 6, and 5. And now we want to swap the first index and the last index, so 21 and 5. And this will be 5, 10, 15, 6, and 21. And this one is like on lockdown. We don't want to bother this 21 anymore. Now we're just going to heapify. We see that 15 is greater than 5. This becomes 15. This is 5, 10, 6, and I'm not going to bother writing this 21. We see that this is heapified, so now I'm going to bring this down again. Then we're going to write the array 15, 10, 5, 6, and then I'm going to bring down this 21, and it's locked. We're not going to bother it anymore. So we are going to swap the index that's not locked and the first index. So 15 and 6. So 6 goes here, then 10, then 5, then 15. We do not want to bother 15 anymore, and we just heapify. So we see that 10 is greater than 6, so we swap them, and that's it. I'm going to bring this down. These are locked. Now we want to swap 5 and 10. So this is 5, 6, 10, which is now locked. So we see that 6 is greater than 5. 6 goes here, and then 5 goes here. We want to bring that down. We see that, oh, this is locked. We see now that we're going to swap 5 and 6. So now this becomes 5, 6. The 6 is locked, so this just becomes 5. So now that it's the only one left, it's essentially sorted. So when we bring it down, we see that it's 5, 6, 10, 15, and 21. And that's heap sort. So this is quicksort. Quicksort uses a pivot. In this case, the pivot is going to be at the median index. So to find, if let's say we're given an even array, we're going to take our first index plus our last index, divide that by 2, and take the floor. That's going to give us our index to get our pivot. But for the array that we're going to use, it's going to be odd. Our pivot is 3. Now what we're going to do is we're going to compare 3 with this side and 3 with the other side. And we're going to have 2 iterators. One that's going to iterate to the right and another one that's going to iterate to the left. So we're going to start. So is 2 the iterator at I greater than or equal to the pivot? No, it's not. And then we're going to do at k is 4 less than or equal to the pivot? 3. No, it's not. So we're going to iterate again. So I is now here and k is now here. And then I'm going to do the exact same comparison. Is 5 greater than or equal to 3? Is 1 less than or equal to 3? In this case, they are both yes. So since they are, I'm going to swap the iterators, 1 and 5. So this is now 1, this is now 5. And then I'm going to iterate, Ri is now at 3, and Rk is now also 3. So we're going to perform a swap of 3 in itself, because if we just compare it, 3 is greater than or equal to 3, and 3 is less than or equal to 3. So 3 is going to swap itself, but it's going to be left alone. Then we're going to iterate again. We see that k is now here and I is now here. Once they cross like this, we're going to partition, and we're going to partition at I. So I'm going to box this. So here, the partition at I. So partition is, we're just going to repeat this whole process, but only on this part. So I'm going to do 2, 1, 3, and we're going to find our new pivot. In this case, it's going to be 1. So we're going to do ik is 2 greater than or equal to 1? Yes. Is 3 less than or equal to 1? In this case, it's no. Because of this, we found we want to swap with, which is 2, because this is a yes, but this doesn't want to be swapped. So we're going to de-iterate k. So this is going to be 2, 1, 3, and k will now be here. I is going to stay the same. And now we're going to do is 1 less than or equal to 1? Yes. So we will swap 1 and 2. 1, and 1 is still our pivot. 2, 3. Then we, with our iterators, so now this is k and this is I, and we see that they cross each other. So we partition at I. We see that this is on its own, so we can already say that this is sorted. Now we're going to do 2 and 3. So this is even, so I'm going to get the median. Right here, the indexes would be 0, 1, 2. So we're going to say 1 and 2 divisible by 2 is going to give us 3 over 2. The floor is going to give us 1. Our pivot will be at index 1. In that case, it would be this one. Here, 2 and 3, our pivot being 2, I and k. 2 greater than or equal to 2? Yes. Is 3 less than or equal to 2? No. So we're gonna do 2 and 3. K will de-iterate, and then is 2, we know this to be true. So then is 2 less than or equal to 2? Yes. So swap is, the 2 is being swapped by itself. So then we just leave 2 and 3, and then we do iterate. So k will be over here somewhere, and then I will be now here. And we see that they crossed. So we partition, and we see that these two are by themselves. So now it's going to be 2 and 3 that are swapped. We're going to come back up and do the partitions for 5 and 4. So 5 and 4, our pivot is 5. I and then k. Is 5 greater than or equal to 5? Yes. Is 4 less than or equal to 5? Yes. So we are going to swap them, 4 and 5. Now k is here and I is here. They are crossed, we partition, we see that they are by themselves, so we can add it. So now it's 4 and 5. And then that's how you do quicksort. So these are all the tracing for the different sortings taught in this class. Thank you for watching.